Alright, so we are going to again be talking about inequalities, but this time we're just going to be talking about inequalities that maybe have a little bit more evolved. But still, it's really just the same thing as solving an equation, it's just a different sign in the middle. So our first one that's in your packet is 5 minus 6n is less than 4n plus 45. So just like a normal equation, all we're going to be trying to do is get all things with a variable on one side and all the constants on the other side. So first I am going to subtract this 4n. I'm going to just make that a little bit smaller. Okay. So if I do it on one side, I must do it on the other side. So I have this minus 4n here. So now we have 5 minus 10n is greater than 45. Okay, and I want to get all the n's alone, so that means I got to get rid of this 5 first. So I'm going to subtract it from both sides. And so we have negative 10n is greater than 40. And now in order to get the n by itself, we know we're going to divide by negative 10. Divide by negative 10. So these cancel each other out, so we get n. Now again, same rules apply. If we divide by a negative, we need to switch the sign here. So this was a greater than, now it's going to become a less than, and then 40 divided by negative 10 is negative 4. Okay, and then the same thing if we want to graph this. We have our number line, and we plot our points. So you're 0, negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, and then up to 1, 2, 3, 4, 5, 6. Okay, so if I go to my negative 1, 2, 3, 4, it's right here. And I know that since it is not filled in, I'm going to leave it open. And we're talking about numbers smaller than negative 4, so it's going to be all these guys over here. So here's my graph. So the answer to my equation or my inequality is any number that is less than negative 4. Okay, so that's our first one in the packet. So now we're going to move on to our second one. So if we look at our second one in our packet, we are going to be looking at, or the second one we're going to be doing, I'm not sure if it's second in your packet, we have 9t minus 5 times t minus 5 is less than or equal to 4 times t minus 3. Okay, so this one here, it's just like a normal equation, and anytime we have these sort of parentheses with this number outside, we should know we're going to use the distributive property. So I'm going to get 9t, and I'm going to distribute this here and here. So negative 5 times t is negative 5t, and then negative 5 times negative 5 is plus 25. It's really important that we don't lose any negative signs. I bring down this, so it's less than or equal to, and now I'm going to distribute my 4 as well. So we're going to get 4t minus 12. Okay, and now just like a normal equation, I'm always going to try to combine like terms first. So I'm able to combine this one. So I get 4t plus 25 is less than or equal to, and we have 4t minus 12. Okay, I can't combine any like terms on the same side anymore. So now what I'm going to do is try to get all the variables on one side, the constants on another side. So if I try to subtract 4t, I get minus 4t, and then I get minus 4t. So we have 25 is less than or equal to negative 12. Because look, 4t minus 4t, those cancel out, that gives us 0. We're left with that 25. And 4t minus 4t, oh, those go away too. So we got 25 is less than or equal to negative 12. So let's just take a look. Is that a true statement? Is 25 smaller than negative 12? No, it's definitely not. That means that there is no solution. So similar to when we're solving an equation, if all of our variables go away and we're left with a false statement, there is no solution. So what that means is there's no number that I can plug in for t. That means that that makes it so that this side is smaller than this side here. Okay, this is a very important concept. So again, the reason that this has no solution is because our variables crossed off, they went away, and we were left with a false statement. Okay, we're going to do one more example together. All right, so if you look at one last example that's in your packet, we have 3 times 4x plus 6 is less than or equal to 42 plus 6 times 2x minus 4. All right, so just like any normal equation, what we're always going to do first is now distribute. If you can't distribute, then you move on, but if you can, you got to do it. So we get 12x, and 3 times 6 is 18. Now we have this less than or equal to, 42 stands alone, and now again, we can distribute over here. So we get 6 times 2x is 12x. And 6 times negative 4 is minus 24. It's really important that you don't lose any negative signs. All right, so we're going to see if we can combine like terms on the same side. Can't combine anything here. This has an x, this doesn't. Over here, we can combine this 42 and this minus 24. So if we think about it, again, we're combining like terms on the same side of the equal sign. So we have 42 minus 24 which gives us 18. So we're going to have 12x plus 18. And then over here, we're going to have 12x plus 18. All right, so now we got to try to get all the variables on one side and the numbers on the other side. So I'm going to subtract 12x over here so I can get it to the other side. I'm going to subtract 12x over here as well. So these go away and we get 18. Sorry about that, 8 there. We bring our sign down. So 12x minus 12x, those also go away. That becomes 0. Now we have an 18. All right, so our variables are here and we have a statement. It says 18 is less than or equal to 18. So is that a true statement? Yeah, because 18 can be equal to 18. 18 is equal to 18. So this right here means we have infinite solutions. Okay, you may also see it as all real numbers written like that. So what that means is any number that you plug in here will make this true. So let's pick a number. So let's pick 0. It's always easy to pick 0. So what I'm going to do is I'm going to plug 0 in here. So instead of x, we have 0. And now instead of x here, we have 0. Okay? So this says 4 times 0, which is 0. Now plus 6 times 3. So 0 plus 6 is 6 times 3 gives us 18. And now over here we have less than or equal to 42. And now 0 here, 2 times 0 is 0, minus 4. Okay, so 0 minus 4 is negative 4 times 6 gives us negative 24, so minus 24. We saw before that 42 minus 24 is 18, so we get that 18 is less than or equal to 18. Is that true? Yes, it is. Okay, 0 is not the only number we could plug in. We also could plug in maybe 2. Okay, so if we were to plug in 2, I'm going to do it over here in green, we would get 3 times 4 instead of x, we know we're putting 2, and then plus 6. Okay, and then we're going to get is less than or equal to 42 plus 6 times 2 times 2 minus 4. All right, so we do the inside first. 4 times 2 is 8. So we get 3 times 8 plus 6. So 3 times 8 plus 6 is 14. And now we're going to do 3 times 14, which is 42. So now we have 42 over here. All right, we carried down our less than or equal to sign, and now we have 42 plus 6 times 2 times 2 is 4 minus 4. So 4 minus 4. So we have 42 plus 6 times 4 minus 4 is 0. 0 times 6 is 0. So 42 plus 0 is 42. So is it true that 42 is less than or equal to 42? Absolutely. So again, what we're recognizing is that any number that we plug in for x will make this a true statement. Okay? So this right here has infinite solutions. All right? So what I need you to do is in your packet, there's one problem we did not do in this video. I need you to complete that. And I also need you to just, in the bottom of the page where it tells you how do you know if you have infinite solutions or no solutions, I need you to just write down what we talked about. Having infinite solutions, how we can tell that we have them is if our variables go away and we have a true statement. No solution if our variables go away and we have a false statement. All right, we are all done. See you tomorrow.